Hi, this is Mrs. Lloyd with Lesson 23, Session 2 for iReady, Math 7, Making Inferences from Samples About Populations. And our learning targets remain the same. Same and different. Think about these. Biking 30 miles in 2 hours. 4 blankets cost $60. 6 people own 90 socks. Pentagon with perimeter 75 inches. This is somewhat of a review of, I hope you see it as, unit rates. On page 487. I think today we're actually going to do a little bit of math. There are 406 students at Destiny's school. Destiny chooses 20 students from her school at random and surveys them about how they get to school. Based on the data from the sample, about how many students in the school should Destiny expect to take the subway? So how many did Destiny survey? 20. How many took the subway? 8. So we could do this several different ways. We could do it as a proportion, or since we've just finished working with percents, we could do it as a percent. What percent is 8 out of 20? I hope that you get 40%. So if there are 406 students in her school and about 40% take the subway, what is 40% of 406? $162.4. Well, you can't have 0.4 of a person, and since we're talking about people, we will round down and say 162 students. Here we go. iReady shows a number line. Or the way we did it, using 40%. And you can think about these. We're not going to answer all of them. Look at the first model. What two quantities does it show a proportional relationship between? Students who take the subway and total students. Look at 0.4 times 406 in the second modelet. How is the random sample represented in the expression? Well, it's represented by the 0.4 because we determined that the 8 out of 20 was 40%. Based on Destiny's random sample, about how many students can she expect to take the subway? Is this the same as the result of finding 40% of 406? Well, when we do 40% of 406, we did get a decimal. So is it exact? No. We had to round down. And I think that's what they're wanting you to see on number 3. And number 4, Destiny's friends Xavier and Sierra also each surveyed 20 students selected at random from the school. Based on their samples, Xavier infers that about 142 students take the subway to school, and Sierra infers that about 183 students do. Explain why both of their inferences are reasonable. Did each of these surveys survey 20 students? So since they were all the same size, these are all reasonable numbers. How can you use proportional reasoning to make an inference about a population from a random sample of that population? Let's go back to the beginning where we had 8 out of 20 riding the subway. We could set it up as a proportion. There were 20 in the sample, but there were 406 in the population. And we could solve this. Sorry. To get 162.4. So we kind of worked it through as a percent because I said that's what we have been working with were percents, but we can also use proportions, and really you're doing the same thing either way. Think about all the models and strategies you have discussed today. Describe how one of them helped you better understand how to use a random sample to make inferences about a population. On page 490, a random sample of grade 8 students at a school are asked whether they plan to take computer science in high school. Of those asked, 15 students plan to take computer science, 5 do not, and 7 are unsure. There are 326 grade 8 students in the school. Based on the sample, about how many grade 8 students in the school plan to take computer science in high school? How many students did they survey? 15 plus 5 plus 7. So how many were in the sample? 27. Do you agree with that? So if we think 15 out of 27 plan to take computer science, if our population is 326, how many of those do you think plan to take computer science? So this is one way you could solve it. Or you could change 15, get 15 divided by 27 as a percent. Let's see if it's not the prettiest. We will have to estimate it, but really we could just do 15 divided by 27 and get our decimal and multiply that by 326. So you can solve it either way, whichever way you see it and think about it. When I solve this, I get 181, and you'll get the same answer either way, 0.1. So we're going to round down and say 181 students. To me, this is faster than solving the proportion. They both work. It's just the quickest way to do the problem if you're looking for the quickest way. Number 8, Yolanda asks a random sample of 50 students at her school what they do after school. Of the 50 students, 30 say they play a sport. Based on the sample, about what percent of students at Yolanda's school play a sport after school? So 30 out of 50. What is that as a percent? If you remember your fractions that you were supposed to learn, you don't even need a calculator. 60%. And number 9, there are 5,119 households in Salvador's town. Salvador surveys a random sample of 20 households from his town. He finds that more than one language is spoken in 4 of the households. Based on the sample, in about how many households in the town should Salvador expect more than one language to be spoken? So 4 out of 20. How many if we did the whole town of 5,119? I get 1,023.8. And since this isn't exact, and that one we could really say 1,023 or 1,024, but in this case, we can round up and say about 1,024. On page 491, Garrett is running for class president. He wants to know if he is likely to win, so his friend Kasumi surveys a random sample of 10 students in his school. Of the 10 students, 7 plan to vote for Garrett. Suppose all 233 students in the school vote in the election for class president. About how many students should Garrett expect to vote for him? So in the sample, it was 7 out of 10. So 7 out of 10 times the whole population of 233 would be approximately 163 students. Kasumi conducts another survey of students in the school in the example. This time he surveys a random sample of 30 students. In Kasumi's sample, 24 students plan to vote for Garrett. Based on this sample, about how many students in the school should Garrett expect to vote for him? So this time we have 24 out of 30 times our population of the school, which was 233. I get 186.4. So we're going to round down and say about 186. You could say approximately 186. I'm just using about because it's shorter to write. On page 491, Kasumi conducts another survey of the students in the school. Oh, no, we already did that part. Part B, sorry. Using Kasumi's surveys, can Garrett know for certain how many students plan to vote for him? Explain why or why not. Keyword here, for certain. It's pretty likely that they're going to vote for Garrett based off of these surveys. But what if the surveys were biased? What if the surveys were only of people that knew Garrett well? So it's definitely not for certain. Alex works at a movie theater. One Friday, she collects a random sample of the type of tickets sold in the afternoon and the evening. She estimates that when 400 tickets are sold on a Friday evening, about 100 will be senior tickets. Is Alex's estimate reasonable? So we're talking about Friday evening. So on Friday evening, how many tickets were in her sample? 45 plus 15, that is 60, right? How many were senior tickets? 15. So what is 15 out of 60? 25%, or 0.25. She estimates that when 400 tickets are sold on a Friday evening, about 100 will be senior tickets. So if we do 25% of 400, do we get 100? We do. So is her estimate reasonable? It is. And we have the math to prove it. Number 3. Students at a certain school have to take an arts or technology class. A random sample of 60 students from the school are surveyed. Each student is asked which class they take. Based on the survey results, which of these statements about students at the school are true? Select all the correct answers. So we know there's more than likely more than one correct answer. There are many excellent dancers at the school. Could we make that inference? Well, it looks like dance has the largest number of students, so we can probably make that inference. About 25% of the students take painting. So the sample was of 60. What is 25% of 60? I get 15. And painting says 15, so that is also true. For every 30 students, about 11 take photography. This shows 11 take photography out of 60 students. So I don't think that's true. Next year, 7 out of every 60 students will take music. Every keyword. This is a sample. Does that mean that exactly 7 out of 60 will take music? No. In a group of 120 students, about 16 are likely to take engineering. So it does say about 16. So this is 8 out of 60. If I multiply both of those by 2, I would get 16 out of 120. So this is also true. And number 4, Keisha surveys a random sample of students at her school about whether they wear glasses. In her sample, 28 students wear glasses. The other 52 students in her sample do not. There are 506 students in Keisha's school. What inference can Keisha make about the number of students in her school who wear glasses? So in her sample, 28 students wear glasses, 52 do not. So how many did she sample? What's our sample size? We call this a sample size. 52 plus 28. That's a total of 80. 28 wear glasses. What inference can Keisha make about the number of students who wear glasses? In her whole school of 506. I think you'll get 177.1. So about 177 students wear glasses. In her school. let's fix that. And I think that was the last one for today. Thanks for watching.